Dark matter. It has an effect, but we don't know what it is. Well, except for those pesky neutrinos. We know they're a thing, right? Well, you all know what that means. We conjecture
Although
ahead.
this is going to be weird, and it's going to be about a different.
Title of the conference was something like Ground Truth or Turtles All the Way Down. And so it seems as though there's one Ruliad. I don't think it rules them all. And it might be just hyper-rulial turtles all the way down.
Yes, it's on the back of an infinite number of hyper-rulial turtles.
Various people are commenting on the outrage of hacking the universe on a MacBook Air.
Hey guys, what's going on? Memes here. So yes, I apologize a little bit for the hyperbole. I just totally felt like doing something with a thumbnail that said Dark Mass Effect. What am I talking about? This was brought to, oh my god, I forget which free AI thing it is. I don't know if you're reverse image search. You should be able to find it. And yeah, I just did Dark Matter combined with Mass Effect. And it gave me some cool stuff and things. And, oh wait. It's not changing. I apologize for that as well. Wow, I'm supposed to be doing a little effect here, trying to weave a little stuff and things going on. All right, here we go. All right, so gave us this. Oh, and this actually is from NASA. So why am I talking about this? Because a lot of times we talk about dark matter. We believe, according to many, it's a thing. We have yet to really figure out what it is. Well, except for neutrinos, they basically don't interact except for like the weak force, and we don't really see them. So because they don't really see a temperature or anything, because I don't know. But occasionally it can happen, and I've seen a couple of little cool do it yourself at home experiments. Be wary. I believe some chemicals are involved. I am not your chemistry teacher. Please consult a professional. But so why do I say this? Because what we're actually saying is we're seeing the effect of something or stuff that's occurring. We'll go into a couple of potential other things, but what is this right here? This is the dark matter core, defies explanation. According to this image, shows the distribution of dark matter. Galaxies and hot gas in the core of emerging galaxy cluster, Able 520. The results could present a challenge to basic theories of dark matter. I think what it is they're saying like this is dark matter and it's drawing matter and things that we can see in. I believe that's what we're saying. So if only there were some dark matter, well, I mean, aside from like neutrinos and to be fair, actually black holes too, because we see the effects of them. That's how we detect them. Otherwise, they're pretty dang dark. But and it went through. Yep. All right. Real quick, another explanation for how space. Okay, no, they're going into. Okay, what is dark matter? By fitting a theoretical model of the composition of the universe to the combined set of cosmological observations, scientists had come up with the composition that we described above. Approximately 68% dark energy, 27% dark matter, and 5% normal matter. What is dark matter? Oh yeah, and this is brought to us by our friends at NASA. We are much more certain what dark matter is not than what it is. I see what you did there, my friends. First, it is dark, meaning that is not in the form of stars and planets that we see. Observations show that there is far too little visible matter on the universe to make up the 27% required by the observations. Second, it is not in the form of dark clouds of normal matter made up of particles called baryons. We know this because we would be able to detect baryonic clouds by their absorption of radiation passing through them. Third, dark matter is not antimatter because we do not see the unique gamma rays that are produced when antimatter annihilates with matter. Finally, we can rule out large galaxy-sized black holes on the basis of how many gravitational lenses we see. High concentrations of matter bend light passing near them from objects further away. But we do not see enough lensing events to suggest that such objects to make required 25% dark matter contribution. That is very, very lovely. What if there was no light going through? I don't know. I guess there's always light, usually. Galaxy-sized black holes. Okay, I mean, if the universe hypothetically was a little bit older than 14 billion, that'd also be enough time for like more black holes and stuff to be around. Just the opinion of a dude on the internet. We continue. What are some potential other things that might be going on here? Modified Newtonian dynamics. MOND, if you would. It was by our friends at Wikipedia. I remember, wasn't there like a model recently where it's like, all right, we just confirmed this physics, and someone else is like, we've confirmed that there's another confirmation that conflicts with this. Glad we have experimental precision. What does it mean? I don't know. Modified Newtonian dynamics is a hypothesis that proposes a modification of Newton's law of universal gravitation to account for observed properties of galaxies. It is an alternative to the hypothesis of dark matter in terms of explaining why galaxies do not appear to obey the current understood laws of physics. Created in 1982 and first published in 1983 by Israeli physicist Mordechai Milgram, the hypothesis original motivation was to explain why the velocities of stars and galaxies are observed to be larger than expected based on Newtonian mechanics. Milgram noted that this discrepancy could be resolved if the gravitational force experienced by a star in the outer regions of a galaxy was proportional to the square of its centrifugal acceleration, as opposed to the centrifugal acceleration itself, as in Newton's second law. Or alternatively, if gravitational force came to vary inversely linearly with the radius as opposed to the inverse square of the radius, as in Newton's law of gravity, MOND departs from Newton's laws at extremely small accelerations that are characteristic of our regions of galaxies, as well as the intergalaxy forces within galactic clusters, which are far below anything encountered in the solar system or on Earth. All right, so it's sounding like if you're not going too fast, it may have an effect. Well, that's very interesting, because that's basically what I took away from the whole like quantized inertia thing from I believe Mr. Doctor maybe Mike McCulloch. And this was a paper, a skeptical analysis of quantized inertia. The whole thing they're basically saying is, all right, if you're accelerating, and as long as you're accelerating at a particular, it has something to do with the unreflected. It will actually go into that in a second there. But as long as you're accelerating not too fast, there's basically less pressure behind you, or you're kind of running away from the light of reality and the universe itself. That's what I kind of take away. It's kind of weird, but apparently the numbers seem to add up. It's basically if you're on the outer end, there's going to be a little less force, and especially I tend to think very often we don't understand all these different things that well, and it's probably a little bit of a lot of different things. What happens if it happens to be more dark matter that maybe we know of? I don't know, maybe like some neutrinos, maybe some black holes or something. Perhaps if the universe as we know it was maybe just a little older than 14 billion years. I'm not saying there wasn't a Big Bang. I totally believe there was. We have like an observed Big Bang because we see different stuff. But I'm just saying, just my opinion, as I'm rampantly conjecturing here. Let's actually just go to the little part here, because there are some strong parts. We'll just go to the weak part. Its main weak point is the fact that it assumes the existence of the UNRRA irradiation, UNRRA 76, which is still not experimentally measured in nature. Although some recent simulations seem to confirm its existence. Who at the hell 2019? Basically that whole, as long as you are accelerating, there's going to be a little bit less stuff potentially behind you. And if that does have some form of an effect, apparently Mr. McCullough claims that it lines up. I mean, that would also be like the easiest explanation. It's like, well, how do these bodies work at extraordinarily grand scales? I don't know. Don't we assume physics usually works up to all the different scales, unless it's quantum? And that's just wacky. We don't really understand that. We can make really precise measurements. We can make extremely precise predictions. But for some reason, on different scales, things seem to get a little interesting. I find that fascinating. But my whole big thing with this all was I really think that things are important. And if we're talking about dark matter, so to speak, if the claim is, what are we observing? We're observing a mass effect. Mass-like effect, it's a dark mass effect. Technically should be invisible, but we like to use the word dark for some reason. And dark mass effect sounds wicked cool. Because apparently a lot of people like Mass Effect. I never played, but I got the Mass Effect Blood Dragon armor for Dragon Age Origins. That's why it's a little close to the chest. And I still need to figure out some mistakes that I did with the Electron the other day. I apologize. It did seem interesting, that particular result. But yeah, that's all we really got. Hey, Matt. Good to see you, my friend. Thank you for joining. I apologize for being a terrible host. But yep, just a little thing out there. A little clickbaity. I apologize. I just thought with the picture, just throwing the lettering and doing something different. I don't know. Maybe a wee bit giddy inside. And I've been meaning to talk about this. So that's all I got for right now. Take care of yourselves, everyone. It's a wacky and wild world out there, but the best is yet to come, I claim. Peace out, everybody.